Hello students, welcome to my YouTube channel. In this video lecture, I am going to answer very important questions of DME from Keith Williams chapter or Keith Williams textbook. The questions I am going to answer are from question 41 to question number 50. So let's start with question 41. Simple. Aircraft is at flight level 410 overhead a DME. What will be the DME indication? So when aircraft is overhead a DME station, okay, it is overhead a DME station like this. Overhead a DME station, the indication, that is this flight level 410, will be indicated as slant range, slant range. So slant range will be flight level 410, that is 41,000 divided by 6,000. 41,000 divided by 6,000 is 6.8 or approximately 7 nautical miles. 42. Aircraft is flying directly overhead at DME at flight level 350. So now here aircraft is overhead this DME station at what flight level? Flight level 350. So 35,000 feet divided by 6,000 is nothing but 0.8 nautical mile or approximately 6 nautical miles. So slant range shown will be 6. Which of the statements is correct regarding DME? The indicated distance is the ground distance measured from aircraft's projected position on the ground to the DME ground installation. Wrong. So if this is your DME station, let's say, and here is your aircraft in the atmosphere. So the DME information is your slant range information. It is your slant range information and not ground range. Ground range information means this, horizontal information. Aircraft's projected position means the shadow of the aircraft on the ground. The shadow of this aircraft on the ground. So this becomes your ground range or horizontal range. Okay, so indicated distance is the ground distance. No. DME operating frequencies are in the UHF band. Yes. UHF band 962 to 1213 megahertz. Two lines of position from two different DMEs give unambiguous fix. Wrong. DME station is always co-located with a VOR. Wrong. Not always. Next. 44. The selection of the DME frequency for ILS DME installation is DME frequency for ILS. That means ILS and DME frequencies are paired. Means if you select ILS localizer frequency, automatically DME will get actuated. The pilot has to insert the channel number. No. When ILS DME is flown, the selection of the DME has always to be done manually. The DME frequency has to be selected. The DME frequency is paired with localizer, so only the localizer frequency is set. Delta is the right answer. Now next very important thing or a few points I want to give regarding ILS and DME pairing. So whenever ILS is paired with DME, remember this information for your ATPL Viva especially or interview. So point number 1, a DME paired with ILS gives accurate ranges from the touchdown zone along the ILS center line. Now you have to pay attention here that all the DME distances when DME is paired with ILS are with respect to touchdown zone. So if this is your runway, this is the touchdown zone, let's say. So all DME distances are with respect to this touchdown zone. But DME station cannot be placed on the touchdown zone of the runway. Can we place this DME station here, right in the center of the runway? No, we cannot do that. So there is some modification done mathematically, and you have to remember this. The result, this particular DME distance result is achieved by altering a transponder fixed delay so that the airborne equipment indicates an incorrect or wrong range from the actual station, but correct distance from touchdown. In simple words, in simple words, DME paired with ILS will give incorrect or wrong ranges in any other direction, in any direction other than this center line direction. So if you are using this DME which is paired with ILS, you will not use this DME in any other direction. This DME is only meant for use along the center line of the runway for this approach, not for any other purpose. So DME paired with ILS will give wrong ranges in any other direction. Very important point. Okay, next. The effect of masking the DME antenna. Masking the DME antenna means hiding the DME antenna from ground station is that interruption of reception of DME signals. Now let's say here is your ground DME station, and in between there are some huge mountains, and the DME receiver on your aircraft or the antenna gets hidden because of this intervening high ground. So any reception or any reply pulse sent by the ground DME station or ground transponder will be blocked by this intervening high ground. And we know that all DME ranges depend on line of sight. That means aircraft must be in the line of sight visible to the DME station. Okay. But in this case, in case of intervening high ground, this will block the uh, transmission or reception of reply pulses by the aircraft antenna. So in this case, what will happen? There will be interruption of DME signals. When interruption happens, as a consequence, lock on. That means the connection between the aircraft receiver and DME station will be lost. And when this happens, the aircraft receiver will switch to memory mode. It will switch to memory mode. What is this memory mode? In this mode, aircraft receiver will continue displaying the previous DME value, just the previous DME indication just before losing the lock on for 10 seconds. Now 10 seconds is the value for old systems. It may be more than this for new modern systems. Okay, continue displaying the previous DME value for 10 seconds at least. And if the lock-on is not achieved during this 10 seconds memory mode, it will switch to a new mode called search mode. In this search mode, it will again start searching for a DME station nearby. Okay, so in the first instance, it switches to memory mode and later on search mode there is failure in if there is failure in receiving this reply pulses successfully in this 10 seconds. So the ground installation not sending any pulse pair, that is wrong. It is sending pulse pair, but they are being blocked by intervening high ground. Airborne installation switches to memory mode for 10 to 15 seconds, yes. Airborne switch directly to search mode, no, not directly. After switching to memory mode, after memory mode, it switches to search mode. Signal controlled search circuit blanking the DME display irrelevant. Next, 46. Which statement about interrogation is correct? Interrogation starts when the interrogator has been warmed up sufficiently. Whether pulse pairs are received or not, wrong. Interrogation does not start before pulse pairs of the tuned DME station are received. Yes. Interrogation will start once you receive the pulse pairs from the DME station. The interrogation can only take place if echo protection circuit has been locked wrong. Interrogation starts directly after the correct DME frequency has been selected on the frequency selecting panel by the pilot. Wrong. Interrogation starts when you successfully receive the reply pulses from the DME ground station. The aircraft DME equipment will send or transmit interrogation pulses to the ground station. The ground station will wait for 50 seconds, microseconds correction, and then it will retransmit reply pulses to the aircraft receiver. Once these reply pulses are received and aircraft has identified them, accepted them, it will achieve a lock on, and from there on the interrogation or the communication between your aircraft and DME station will begin. Okay, so Bravo is the most suitable option. The ident of a DME in case of co-location with a VOR is what? So very important. I explained this in my previous video lectures. When DME and VOR are co-located, the identifications are shared or paired, meaning there will be 4 identifications transmitted every 330 seconds. The first 3 will belong to VOR and the last identification will belong to the DME station. And the identification belonging to DME will be on a higher pitch tone. Okay, so the answer here will be the ident of a DME in co-location with a VOR. In 30 seconds, the DME identify comes up 3 times? No. The VOR identification comes 3 times, DME comes for 1 time. In 40 seconds, DME ident will sound once? Yes. First 30 seconds, you will hear VOR identifications 3 times. And in the last 10 seconds, you will hear DME identification for 1 time. In case of co-location, DME ident is unnecessary wrong. The DME ident comes every 10 seconds at an audio frequency of so and so wrong. 48. What are the correct statements? Statement 1. The interrogation signal is transmitted on the same frequency as the reply signal. Wrong. DME based on secondary radar. A secondary radar is that radar which uses one frequency for transmission and a separate or different frequency for reception. So statement 1 is wrong. DME station always has a transponder delay of 50 millisecond. It is 50 microsecond, not milli. So second option 2 or statement 2 is also wrong. So we are left with option delta 3 and 4. The time difference between the pulse pair of the interrogation signal is at random. Yes, this is called jittering. This is done so that every aircraft will have its own unique pulse or pulse pair. So every aircraft will accept only that reply pulse or only those pulse pairs coming from the ground station which are unique to them, which are meant for them. And this is achieved how? How is this achieved? This is achieved by uh, changing the pulse timing between two pulse pairs. Let's say this is your aircraft 1, aircraft number 1. The time interval between its pulse pairs will be, let's say, 5 seconds. For example, there will be aircraft number 2. There is an aircraft 2, and the time interval between its pulse pairs are let's say 8 seconds. So this aircraft 1 will receive only those pulse pairs from the ground station which are at an interval of 5 seconds. This will accept only those reply pulses which are at an interval of 8 seconds, right? So third is right. Fourth, in the search mode, pulse pairs per second are transmitted more than in the tracking mode. Yes, in the search mode, aircraft is in the search mode, it transmits 150 pulses per pulse pair per second for 100 seconds. In this 100 second, if lock on is not achieved, it will cut down or it will decrease or reduce the scan rate is reduced to 60 pulses per second. If lock on is achieved successfully, the scan rate reduces to 25 to 30 pulses per second. Okay, so definitely, or of course, 150 is more than 25. So in search mode, more pulse pairs are transmitted. So fourth is also right. 49. A fix obtained by row navigation is based on what information? So in navigation, row means DME distance. Theta means VOR radial. So row means distance, distance. So fix obtained by distance is based on information from two DMEs. You will get distance information from two different DMEs. 50. Let's say here is one DME station. There is another DME station. Your position is here, somewhere here, which is nautical miles from this particular DME and 50 nautical miles from this particular DME. So you can pinpoint your position. 10 from here, 50 from here. So this is called row information obtained from two different DME. The reason for using different frequencies for airborne equipment and ground equipment for in case of DME is to prevent reflections of ground interfering with DME operation. Delta. To prevent DME interrogation pulse pairs from being received by aircraft after reflection on the Earth's surface. DME is based on secondary radar principle. So aircraft DME equipment will transmit radio pulses at a particular frequency. This interrogation pulses will reach the ground station. Okay, it will reach the ground station. will reach the ground station, and the ground station will wait for 50 microseconds and retransmit this radio energy at a frequency which is plus minus 63 megahertz. Okay, 63 megahertz different from the interrogation frequency. And this helps in uh, preventing ground reflections from hampering your DME operation. In case of primary radar, you use one frequency throughout the cycle. The transmitted frequency is the same as the reception frequency. So you keep getting reflections from aircraft, you keep getting reflections from ground, mountains, any obstructions. But in case of secondary radar, you will only get the aircraft will only accept that reply pulse which will be coming from the DME ground station at a different frequency, and it will eliminate all the ground returns, all the ground reflections which are at the same frequency as that of the transmission. Okay, so ground reflections will have the same frequency as the transmitted frequency. So the aircraft DME receiver comes to know that, and it will eliminate them, disregard them, okay, reject them. So correct option is delta. I'll stop here. I hope you have understood all the 10 questions, the explanations, the concept, and the why, the logic of selecting a particular option. So remember the why, remember why we are doing or why we are selecting a particular option, the explanation or the justification behind that. So this will boost up your preparation, your confidence, and increase your conceptual clarity. I wish you all the best. Subscribe to this channel if you haven't yet. Share this video with your friends and hit the like button if you have not liked this correction, if you have liked this video lecture. Thank you for your time. In the next video lecture, I will answer the next 10 questions. So don't miss that. Thank you.